Hello everyone, welcome to another video on differential calculus. Like I promised in the previous video, today I want to look at past exam papers again, and I'll be specifically focusing on the 2023 June exam. That's paper 1, Gauteng Province, Republic of South Africa. And then after that, I'll be going to the same year, 2023 preparatory exam paper 1, and finally I'll be looking at the final exam. That's 2023. So let's go straight into the question we're targeting. In this paper, we're targeting question number 6. As you can see, question number 6 is the question that covers first principles and rules of differentiation and a bit of application there of the derivative. We're going to explain how you go about that. So this is basically question number 6 in the June exam of 2023. I want to go through this as quickly as I can, and then I move on to the next one. So let's look at question number 6.1. It says f of x equals 3x minus x squared. Use the definition that's from first principles of the derivative to calculate f prime of x, and it's 4 marks. A little bit mean there, but we'll see how the 4 marks are distributed. 6.2, we are determining dy dx of these two functions, and we know that dy dx is another form for f prime of x, another form for the derivative of the function. And then we are given a function here, that's 6.3, a function h is given by h of x equals ax squared plus b over x, and has a minimum value of 12 if x equals 2, or at x equals 2. And then we're supposed to determine or calculate the values of a and b. Right, so let's go straight to 6.1. Question number 6.1. So this is 2023 June exam, 2023 June exam. That's this is question, that's obviously paper 1, and we're focusing on question number 6. Right, let me call this page 1. So question number 6 here, 6.1 says we're given f of x is equal to 3x minus x squared, and we're supposed to determine f prime of x using first principles there. So we can say therefore f of x plus h will be equal to 3x plus h minus x plus h all squared. Expanding this, it gives us 3x plus 3h, and then minus, remember here what I told you last time, x squared plus 2xh plus h squared. Expanding or removing those brackets, we're going to have 3x plus 3h minus x squared minus 2xh minus h squared. And then we move on straight to the formula now. The formula says f prime of x will be equal to limit as h approaches 0 of f of x plus h minus f of x all over h. Substituting these two expressions into the formula, this will be equal to limit as h approaches 0 of 3x plus 3h minus x squared minus 2xh minus h squared minus open brackets, we put that expression in brackets, 3x minus x squared, like this, and we're dividing this whole expression by h. In the next step, we simplify. Make sure you leave out spaces so that it's easier if you make a mistake to be able to spot where the mistake is. Limit as h approaches 0 of 3x plus 3h minus x squared minus 2xh minus h squared minus 3x plus x squared all over h. Now this cancels that, and this cancels that. So what do we have in the numerator? We have limit as h approaches 0 of 3h, that term there, and then we have minus 2xh, that term there, and then we finally have minus h squared, that term there, and all over h. Factorizing the numerator, we have this is going to be equal to limit as h approaches 0 of h common factor, we have 3 minus 2x minus h, and all over h, and the h cancels. Next step, we have limit as h approaches 0 of what? Of 3 minus 2x minus h. And as h approaches 0, minus h will approach 0, and therefore our final solution is going to be 3 minus 2x, and that's our final solution. How are the marks distributed? The 4 marks. If you notice here, this question in this paper had 4 marks. Normally it's supposed to be 5 marks, but this one has 4 marks. So let me show you how I would distribute these 4 marks. This is according to me. The examiner may have wanted a different mark distribution, but in my case, I'm going to give 1 mark for that, and then I'll give, because it's 4 marks, I would give 1 mark for that. So that will be substitution and simplifying all the way up to here, and then 1 mark for the common factor and cancelling, and then 1 mark for the final answer. So that would be 4 marks. Right, let's move on to the next question here, 6.2. We're going to, so this one is rule of differentiation 1, which is first principles, and then and I must say that first principles in the whole paper, it's only going to be 1 question where they require you to use first principles, and they must say it that they want you to use first principles. Otherwise, do not use first principles, because it's quite time consuming. All right, let's move on to question number 6.2. So this is going to be my page 2. Question 6.2. Here it is. We're supposed to determine dy dx. So 6.2.1, let me put it here. I'm going to bring it up. 6.2. And we have 6.2.1. The question is, y is equal to x minus 3 square root of x all over x squared. We're supposed to determine dy dx. So the first thing you're going to do here is what we call term-wise division. So simplify this. In other words, this will be equal to x all over x squared. You do this term-wise division only when there's a minus sign here or a plus sign. If there's multiplication sign, you don't do that. Division, you don't do it. You divide only once. In this case, we're allowed to do that. And so it's going to be minus, and I'm going to write 3x power 1 over 2. Remember, square root means power half, all over x squared. And now what we need to do now is to understand that there's a power 1 there, and here you have power half, down there power 2. And when terms of the same base are dividing, you subtract the powers. So this is going to be x the power minus 1, because 1 minus 2 is minus 1. And then we have minus 3x the power half minus 2 is minus 3 over 2. You can verify that. Let's just try to do it. 1 over 2 divided, subtract 2. If you notice, it's exactly 3 over 2, minus 3 over 2. So that's what we have. Next, we now are in a position to determine dy dx. So therefore, dy dx, remember, using power rule, we're going to take the minus 1, multiply, and then reduce the minus 1 by 1. All right, and then we have 3, and then minus 3 over 2, and then x power minus 3 over 2, reduce that by 1. Simplifying this, it gives us minus x power minus 2, and then here you have a positive, because minus times minus is positive, 9 over 2, and then you have x the power minus 3 over 2 minus 1, it's supposed to be minus 5 over 2. Again, please revise your exponents, minus 3 over 2, and then minus 1, minus 5 over 2. There it is. So that's what we have. Now, respecting, like I said in the previous video, the format in which the question has been presented, we have a square root sign here, and we have all the powers of x are positive. We're going to write this as this being equal to minus 1 all over x squared, and then plus Remember, this one here has to come down into the denominator. So it's going to be 9 all over 2. And let me take step by step, x to the power 5 over 2. And if I may go on to the next level here, or next step, I'm going to have minus 1 over x squared, and then plus 9 all over this part here, x power 5 over 2 is actually square root of x power 5. So it will be 2 square root of x power 5. So that would be the final solution. Like I said in the previous video, they are not very strict when it comes to presenting your final solution, respecting the format in which the question has been presented. Unless they specifically say that you must leave your answer with positive exponents, coming down here will just be showing that you know what's going on, but otherwise the marks are not going to be awarded for that part there. The marks are going to be awarded for that. So let's look at the number of marks for this one. It's also 4 marks. You can see here it's also 4 marks. My distribution of the 4 marks, this is how I would distribute the 4 marks. I would give a mark for that, and I would give a mark for that expression, and then I would give a mark for that term there, and I would give a mark for that. So that's how the 4 marks would be distributed. So this part here, you go there, especially when you're required to do so. Otherwise, it's absolutely not necessary. Right, let's move on to the next question here, because we have many, so we're trying to be time conscious. This question here, 6.2.2 says y over 3x equals 1 plus x power 2. So let me try to squeeze it in here. So 6.2.2, what do we have? We have y over 3x is equal to 1 plus x power 2. So the first thing we have to do here is to simplify that or expand it. So this, if you'll agree with me, it's going to be 1 plus 2x plus x squared. If you remember my lesson on algebra, I presented this to you, 3x. Next, multiply throughout by 3x. So you're going to have on the left hand side y equals this 1 here times 3x, it will be 3x. 2x times 3x, it will be 6x squared. 6x squared. 3x times x squared, it will be 3x cubed. I'm doing this because of space here. Now I can say therefore dy dx is going to be equal to derivative of this, as you have seen in a previous video, it will be 3. Derivative of 6x squared, it will be 12x. And then final derivative of 3x cubed, it will be 9x squared. So this would be the final solution right there. Dy dx would be given by that. How are the marks awarded? If you check here, the number of marks, again, it's 4 marks. This is how I would distribute the 4 marks. I would put a mark on simplification, that expression, simplifying, expanding that and multiplying by 3x on the left and on the right. And then I would give 1 mark for 3, 1 mark for 12x, and 1 mark for 9x squared. So that would be 4 marks. Right, let's move on to the next question there, that's 6.3, which would be the last one in this paper, the June 2023 paper. That's Maths paper 1. 6.3. 6.3, and that's our page. This was page 2. Now this is our page 3. 6.3, a bit of application there of derivative. It says this function, h of x, which is given by ax squared plus b over x, has a minimum value of 12 at x equals 2. So which means if you replace that by y equals this, the minimum value of y at x equals 2 is 12. So in other words, we have a point here. 2, 12 is a point on this function, if you understand what this question is trying to say. So that would be our first equation, and I'm going to say something. So let's first put down what we know. So what we know is h of x is equal to ax squared plus b over x. We are told this has a minimum of 12 at x equals 2. So it means that I'm going to say, therefore, y is equal to h of x is equal to ax squared plus b over x. And so this implies, so we're going to say at x equals 2, we are told y is equal to 12. Let's perform double substitution. At 12, at y we put 12. So this implies 12 will be equal to, and at x we put, where there's x we put 2. So this will be a 2 squared plus b all over 2. Simplifying this, it gives us 12 is equal to 4a plus b over 2. Simplifying this equation further, multiply throughout by 2, you are going to get 24 is equal to 8a plus b. Remember, 2 here will cancel. So I'm going to rewrite this. Let's just call it equation number 1. That's equation number 1. The next equation is going to come from the word minimum. So from your knowledge of functions, you will agree with me that suppose you have a function that looks like this. I'm not saying that's how that function is going to look like, but suppose you have a function like this. And if this is where your y-axis is, so that point there would be the what we call local minimum. In other words, minimum around that region there, because you don't know what's going to happen this side, because there'll be an arrow here and an arrow there, whether it to go down further this way or that way. But we are basically saying at this point here, the minimum would be something like 12, the question says. And if you go to the y-axis, let's say go to the x-axis here, it's basically saying at 2, the minimum value is 12, which means 2, 12 is a point on the function. In this case, it's h of x. So basically, this is what it's saying. And the other thing I want you to notice is that at minimum or maximum, at minimum or maximum, so maximum would be something like this, minimum would be something like this, like I said. At the minimum, a tangent there is a horizontal line. A tangent is a horizontal line, and you know the gradient of a horizontal line from your knowledge of analytical geometry is actually 0. So m tangent is 0. Here also m tangent, subscript tangent there, m tangent equals 0. So m tangent equals 0 at the minimum. So basically what I'm trying to say is that if we differentiate this, we're going to get the gradient of a tangent. And that tangent at x equals 2, the gradient must be 0, because we're told it has a minimum at x equals 2. So basically I'm saying h prime of x, if we differentiate this, is going to be, and I want to put this one up on this side here and say h of x is equal to ax squared plus b x power minus 1. You must remember to write every term as a power of x first before you can perform differentiation. So I'm coming here now and I'm saying that is 2ax, differentiating this part here. And if you differentiate that part, you're going to get plus b minus 1 x power minus 1 minus 1. Take note of that. Let me remove this part here. My pen misbehaved a little bit there, so let me remove that it doesn't confuse somebody. Right, so now what's our next step? Our next step is going to be to say that this must be equal to 0, because the derivative at it's 0, not anywhere else, at x equals 2. The question has given us that. So let's rewrite this. This is going to be 2ax minus b x power minus 2 equals 0. Rewriting this, 2ax minus b over x squared is equal to 0. Where? At x equals 2. Don't forget that. At x equals 2. Now, punching 2 in here, we're going to get the following. 2a, x is 2, remember, minus b all over 2, and it has to be squared, equals 0. This is 2. Let me take step by step. A times 2 minus b over 4 is equal to 0. Now multiply by 4 throughout. Remember, this is 4a minus b over 4 and the answer is 0. Multiply by 4 throughout. This times 4, you're going to get 16a minus b. Multiply by 4 there, it will be minus b. Multiply by 4 on the other side, it will be 0. So this would be equation number 2. We're supposed to solve the two equations simultaneously in order to be able to determine the value of a, values of a and b. So our first equation is this one. This is our second equation. Let me rewrite the equations on my page 4. Page 4, what am I trying to say? I'm trying to say that looking at the two equations together, we have, so this is question 6.3, continuation. So equation number 1 is 8a plus b equals 24. There it is. 8a plus b equals 24. That's number 1. Equation number 2 is 16a minus b equals 0. So 16a minus b is equal to 0. These are very easy equations to solve. By elimination method, we just add equations up. So 8a plus 16a is 24a. Positive b plus minus b, the answer is 0, so b is eliminated. 24 plus 0 is actually 24. Next, we have to divide both sides by 24, so get 24a over 24 equals 24 over 24. This tells you that a is actually equal to 1. Right, a equals 1. So we now are supposed to determine the value of b. We can use either one of the two equations. Let me check the second one is easier for me. So I'm going to say, picking equation number 2, that was equation number 2. As you can see here, we named it as equation number 2. What does equation number 2 say? It says 16a minus b is equal to 0. What's the value of a? A is 1, so it must come here. So it will be 16 times 1 minus b equals 0, and this will be 16 minus b equals 0. Take b the other side, you're going to get 16 equals b. So we can finally say, therefore, a equals 1, comma, and your b equals what? 16. This is 7 marks. And if you notice here, there's nothing special we have used here apart from two ideas. And these ideas are that the minimum of 12 at x equals 2 gives us a point. Gives us a point here. It gives us a point of 2, comma, 12. Remember, that will be x axis and that will be y axis. And that's 1. Number 2, we have used the understanding that gradient of a tangent at minimum or maximum m tangent equals 0. And so we differentiated the function and equated to 0 over here. You can see it there. We differentiated and equated to 0 and simplified the equation, substituted the value of x and obtained this equation here, the second equation, and we solved the two equations simultaneously as I have demonstrated to you over here. Right, so let's look at mark distribution and how are the 7 marks distributed. Well, according to me, this is how I would distribute the 7 marks. 1 mark would be for setting up the equation here, setting up the equation there, basically equating, substituting 2 and equating to 12. That would be 1 mark. Simplifying the equation would give me 1 mark also. The other mark would be here, derivative equal to 0, 1 mark. And then I would give 1 mark for simplifying, obtaining the equation. This one here, I would give 1 mark also. 1 mark also there. And then, so that would be 4 marks. These are how many? 7 marks. All right. So I'd give another mark where I would give another mark at where I substituted a 2 there. I would give a mark for substituting a 2. So that's 5 already. And then the other mark would come straight at a equals 1 and b equals, the other 2 marks would come there. A equals 1 and b equals 16. And that would be our 7 marks. So that's 5. You can see here 5 and then plus the 2, that will give you 7 marks. It doesn't really matter where you place that mark, either here or here, it's the same for a equals 1. So that's how you would get your 7 marks. So this was 2023 grade 12 maths paper 1 June exam for Gauteng in the Republic of South Africa. Now, I would want to look at the next question here because we're going through past exam papers. So I think to try and restrict the video to only 2 minutes, 5 minutes or 10 minutes would not be doing these concepts any justice. So I'm going to move to the next question paper. The next question paper would be the preparatory exam 2023. I hope you can see it clearly there. Yes, you can. So in this one, I'm going to again focus on the same question, rules of differentiation, and a bit of application. So here we go. Question number 8. Question number 8, we have the question here. It says, determine f prime of x from first principles if f of x equals 3x squared minus 6. And then the second one is determining the derivative of that by obviously using rules of differentiation. And then we're given a function. We're supposed to say determine value of x, determine the interval for which f is concave up. I'm going to explain what that is. Like I told you, they'll always add up a question or two here. It will not just be first principles and rules of differentiation. There will be another item there added for 4 marks or 3 marks. Here, in the June exam, it was actually 7 marks, as you can see. This additional question, which has something to do with differentiation, has 7 marks. So it will be first derivatives, first derivative, of course, by using first principles, and then rules of differentiation, and there will be a question there that requires you to apply the concept of derivative. So here it's the same thing. There is a question there that requires application of the concept of derivative. Now, going through many exam past papers like this gives you the confidence you need for you to be able to tackle the final exam brilliantly. So let's look at this one then. So this is 2023 preparatory exam. So this is 2023. I'm gonna just say here 2023 prep exam, and basically we're talking about Hauteng, and of course it's maths paper 1, and I'm focusing on question number 8 in this case. Let's call this our page 1 for this specific past exam paper. So question number 8, going straight into it. Question number 8, 8.1 says we are told that f of x is equal to 3x squared minus 6. There it is, 3x squared minus 6. And we're supposed to determine f prime of x from first principles. So how do we go about this? Well, this is repetition. F of x, therefore, plus h is equal to 3. X plus h, we square that, and then minus 6. Remember, the only term that is affected is the term containing x or a squared. This is a constant term. It remains a constant term. Now let's expand this. So this is 3. Like you have seen in the previous videos, this will be x squared plus 2xh plus h squared minus 6. Expanding or removing those brackets, we have 3x squared plus 6xh plus 3h squared, and then minus 6. Next, we move on to the formula f prime of x. The formula says limit as h approaches 0 of f of x plus h minus f of x all over h. Substituting the two expressions into the formula, this will be equal to limit as h approaches 0 of 3x squared plus 6xh plus 3h squared minus 6 minus, remember you are supposed to use brackets for that expression, 3x squared minus 6. Like I say, when I'm presenting this information in class, if you don't put these brackets, you are finished. All over h. We move on. Limit as h approaches 0. This will be 3x squared plus 6xh plus 3h squared minus 6 minus 3x squared plus 6 all over h. These terms cancel. As you can see, the constant term there also cancels out. What do we have next? Limit as h approaches 0 of 6xh plus 3h squared. Those are the only two terms remaining in the numerator, all over h. Factorizing the numerator, we have limit as h approaches 0 of h open brackets 6x plus 3h all over h. The h cancels. What is your next step? Limit as h approaches 0 of 6x plus 3h. You'll agree with me that as h approaches 0, 3h will approach 0, and our final solution therefore is going to be 6x. That's your final solution. How are the 4 marks distributed? Again, this one has 4 marks. As you can see, it's 4 marks there. How are these 4 marks distributed? I will say as follows. You're going to get 1 mark for that, and I will have 1 mark for that, substituting and simplifying all the way up to there. 1 mark for the common factor and cancellation, and 1 mark for the final answer. So that would be 4. Right, let's move on to 8.2. It's going to be our page 2. 8.2. That's page 2. 8.2. Basically, it says here, f of x is equal to 2 square root of x minus 1 over x all squared. And we're supposed to find f prime of x. There it is. 2 square root of x minus 1 over x all squared. We're supposed to determine the derivative of that. And how many marks? 5 marks. All right. So we're going to do the simple expansion of this first. And if you remember what I have said in the previous lessons, I have told you this is the square of a bracketed expression. How do you expand it or remove the brackets? That multiplied by itself, it's going to be 4x. Let me explain to you. 2x, 2 square root of x times 2 square root of x. Let me use that for multiplication. 2 times 2 is 4. Remember, square root of x is x power 1 over 2. And then we're multiplying this by x power 1 over 2. That one and that one. Same base, what are we supposed to do with the powers? We add them. So be 1 over 2 plus 1 over 2. What is this? This is going to be 4 power 1. And what is 4 power 1? Well, that's 4x. So that's the first part. And then I'm going to multiply these two together and then double the result. Remember, basically I'm saying, if you remember my lesson on algebra, I said a plus b, if they say square this, or even minus, it doesn't matter. It's going to be a squared, in this case plus 2ab, and then plus b squared. If I have a minus here, a minus b all squared, it's going to be a squared minus 2ab plus b squared. Right, so using the same understanding, I'm going to have here, there's a minus sign, so minus 2, and then I'm going to have 2, remember, don't forget this, this here is x power minus, x power half, not minus 1, x power half, this one here. So I'm going to rewrite that, x power half, and then multiply by 1 over x is the same as x power minus 1. Don't forget that. And then I'm going to have to say plus 1 over x times 1 over x. If you want, you can also have x power minus 1. And we're supposed to square that, or in other words, multiply that by itself. So let's simplify this. And this is 4x. And here I'm going to multiply this out. I'm going to also get minus 4. But half, remember these bases are the same, so I must add the powers. Half plus minus 1 is minus half. So it is x power minus half. And then I have plus x power minus 2. Notice the power inside, power outside, you multiply the two powers. Right, now we are in a position to perform the differentiation. And we're going to use power rule and or other rules apart from first principle. So we're going to say, therefore, f prime of x is going to be equal to, that part there, obviously it's going to be 4 because derivative of x is 1 times 4 is 4, minus 4. Remember the power rule says multiply the power and then reduce the power by 1. So 1 over 2 minus 1. And then plus, multiply the power, reduce the power by 1. Right, simplifying the powers and exponents, we have 4, and here it's going to be plus, obviously, and 4 times half is 2, and then x power minus 1 minus minus 1 over 2 minus 1. It's actually minus 3 over 2 here. Minus 1 over 2 minus 1 is minus 3 over 2. There it is. So minus 3 over 2. And then here we have minus 2x power minus 3. Like I always say, respecting the format or the order in which the question has been presented, I would go a step further and say this is the same as 4 plus, firstly, 2 over x power 3 over 2. Remember laws of exponents. And then I'm going to have to say minus 2 all over x cubed. Then this part here must be rewritten as 4 plus 2 all over. This will be square root of x cubed. So square root of x cubed, and then minus 2 all over x cubed. This would be your final solution, right? But like I've said in the previous videos, they are not very strict whether you present your final answer in that format or not. How are the marks distributed? The 5 marks which we have here, how are these 5 marks distributed? Well, as follows. 1 mark would be simplifying up to that form, up to that stage. That's 1 mark. Simplifying the whole of that expression all the way up to there. This guy is just simple expansion and putting all the necessary terms together and getting everything in order. You have 1 mark for that. And then the other mark would be placed. Take note of that. Oh, this part here is just making sure that you present it in that way. But otherwise, the mark will come here, there, and there. So that will be your 4 marks there. How many marks does this one have? It has 5 marks. So I've been a little bit, I have been a bit, oh, the other mark is going to be, for just expanding the this one here into that format. So this would also give you a mark. And then cleaning up, you'd get a mark also for that. So that will be your 5 marks. So this is not actually 4, it's 5 marks. So please take note of that. But this is my distribution of marks. The examiner may decide to distribute the marks in a different way, but this is how I would award the 5 marks. Right. Let's now move on to the last question in this paper. This was the 2023 preparatory exam, question number 8. So 8.3, the last one in this question paper. It says f of x is equal to 3x squared. Is it 3x squared? Oh, 3x cubed minus 3x squared plus 6x plus 2. Sorry, minus 2. Here it is. There it is. F of x equals 3x cubed minus 3x squared plus 6x minus 2. Like that. What are we supposed to determine? It says determine the interval for which f is concave up. Now, again, we are looking at application of the derivative. There are 2 things I'm going to say there on concavity. You must always remember concavity. For any function, so cubic function, for example, this is said to be concave up. This is said to be concave down. And please take note of this. I'm going to put a line there like so. Please take note of this. This one here, concave up, the condition for a cubic function is that the second derivative must be positive. For concave down, the condition for that is that the second derivative must be negative. Of course, in the next video, we'll talk about the inflection point, right? I'm basically saying, suppose you have this as your cubic function. The inflection point will be somewhere there. This is a point where the average point, so to speak, the value of y there and the value of y there. This, let's say, call this y1 there, y2. This point here is going to be the average of the 2 values in terms of y values. So x values, if this is going to be x1, moving up, this will be x2. That point there is going to be the average point. If you understand midpoint formula, it will be x1 plus x2 over 2, and it will be y1 plus y2 over 2. That's why we call it the average point, the inflection point. Now from here, at this point here, obviously, at least for some of you that have already gone through this, the second derivative at that point, which is the inflection point, must be 0. F prime prime of x must be equal to 0 at the inflection point, the average point. But otherwise, from here going to the right hand side, double prime must be positive. From here going to the left, double prime must be negative. So this is the concept that is actually tested in question number 8.3. So all we need to do is to differentiate it 2 times and form that inequality. Which inequality am I talking about? This inequality here, f double prime is greater than 0. So let's look at the first derivative then. Therefore, f prime of x is equal to, multiply out, it will be 9x squared, and then multiply out, it will be minus 6x, and then derivative of x is 1 times 6, it's going to be 6. Derivative of constant is 0, so the minus 2 falls apart or falls off. So this would be your first derivative, using the power rule and also other rules that I've explained to you in the previous lessons. If I continue now, I'm going to say, therefore, f double prime of x will be equal to, I differentiate this, right? I differentiate that to form this, which is my first derivative. I want my second derivative. I'm coming on this one now, and I'm going to differentiate the first derivative. So it's going to be 18x, if you agree with me, minus 6. 6 is a constant, it falls off. What is the condition? The question says, for concave up, the question says concave up, there is the condition for concave up. So we're going to say that this expression here should be greater than what? 0. So therefore, for concave up condition, comma, f double prime of x, and basically this is what it is. F double prime must be greater than, strictly greater than 0. So what are we saying? We are saying, let me just check this out very carefully there now. It says here, determine the interval for which f is concave up, and this is x cubed, 3x cubed minus 3x squared plus 6x minus 2. Differentiating, I'm just going through this again. This is going to be 9x squared. Yeah, it will be 6x plus 6. Differentiating this again, it will be 18x minus 6. Right, that's correct, my second derivative. So let me finish it off on page 3. Page 3, what am I saying now? I'm saying, therefore, 18x minus 6 must be greater than 0. So 18x must be greater than 6. And what do we have? 18x must be greater than 6. Divide by 18 both sides. X will be greater than 6 over 18. This tells us that x will be greater than, actually, 1 over 3. So in other words, this is what you would get. Here it says, determine the interval for which f is concave up. Yes, so this is the interval. F is concave up from x equals 3 going to the right hand side. Yeah, this is the expression I've got here. I'm not very happy with this, but let me just check the question again. 3x cubed minus 3x squared plus 6x plus 2. Differentiate that, it will be 3 times 3, that will be 9x squared, yeah, less 1. This is 6x, and then that will be 6. Differentiating again, it will be 18x minus 6. Perfect. Everything is just as indicated here. Right. So let's put show you the mark distribution. Here it's 4 marks. So you would get a mark for the condition. Which condition? That condition there, 1 mark. You'd get a mark for the first derivative. You'd get a mark for the second derivative. And finally, you'd get a mark for the final answer, which is that one there. This is how I would distribute the 4 marks. 4 marks, right? It's already 44 minutes. Let's carry on. Quite a lot of time, but let's carry on to the last paper now. The last paper is 2023 final exam. There it is. 2023 final exam. We are supposed to do all these calculations for 13 marks. Let's just give it a go. Right. So the first one here says determine f prime of x from first principles if f of x equals minus 4x squared. Right. So I'm going to go straight because time is a bit of a problem. So this is 2023 grade 12, 2023 grade 12, mathematics, paper 1. This is final exam. As I've indicated here, this is RSA, Republic of South Africa, and I'm focusing on question number 7. So let's look at 7.1 then. 7.1, it says f of x equals minus 4x squared. Minus 4x squared. We're supposed to differentiate that using first principles. So therefore, f of x plus h will be equal to minus 4x plus h, all squared. Minus 4, like I've said in the previous videos, this is what you have, plus h squared finally there, and then we expand this out, minus 4x squared minus 8xh minus 4h squared. Going into the formula, f prime of x, the formula says this is limit as h approaches 0 of f of x plus h minus f of x all over h. Simplifying this, this is going to be limit as h approaches 0, substituting, these two expressions into that, you're going to get minus 4x squared minus 8xh minus 4h squared minus open brackets, remember, minus 4x squared. You must always use brackets there, all over h. Again, expanding, removing those brackets, we have limit as h approaches 0 of minus 4x squared minus 8xh minus 4h squared plus 4x squared. These terms cancel. Of course, we're dividing this by h. Next step is limit as h approaches 0 of minus 8xh minus 4h squared all over h. Factorizing the numerator, this is limit as h approaches 0 of h minus 8x minus 4h all over h. The h cancels. We have limit as h approaches 0 of minus 8x minus 4h. As h approaches 0 minus 4h approaches 0, your final answer is minus 8x. That would be your final answer there. How are the marks distributed in this one? The 4 marks, this one has 5 marks actually. 5 marks, which is the normal number of marks. Those marks are distributed as follows. It will be, as you've guessed, like so. That will be your 5 marks. Simplifying f of x plus h, substituting the two expressions, simplifying, and then finding the common factor and cancelling, and your final solution there. That will be 5 marks. Right. Let's move on. So this, let's call it page 1 for this specific examination question paper. I'm moving on to page 2. Page 2, and this is question number 7.2 now. Rules of differentiation. So 7.2.1. So we are told f of x is equal to 2x cubed minus 3x, and we're supposed to determine f prime of x. So we're going to say f prime of x is equal to 2 times 3 x power 3 minus 1 minus 3 times 1, because derivative of x is 1, as you would recall from the previous video. So this will be 6x squared minus 3. That would be your final solution. This one has 2 marks. Marks are going to be given just for accuracy. That's 1 mark for that and 1 mark for minus 3. So that should be 2. Moving on to 7.2.2, we have, remember I've given you this form of derivative, 7, and then it says cube root of x squared, and then you have plus 2x power minus 5. So the problem is here, we have to simplify that. Please take note of notation here, maintain that expression outside there, the differential operator, and then this part here is going to be, remember, 7x power 2 over 3. The 3 must divide into the power, and then plus 2x power minus 5. Now the two terms are expressed in powers of x. We now can differentiate, and when I'm differentiating, this one drops off. So this will be 7 2 over 3 x power 2 over 3 minus 1, and then I have plus 2 minus 5, or x minus 5 minus 1. Simplifying this part here, it's going to be 14 over 3 x power 2/3 minus 3 minus 1 is actually minus 1 over 3. So let's try 2/3 minus 1 minus 1 over 3. So this is minus 1 over 3, and then here it's going to be minus 10 x power minus 6. Again, writing in the format in which the question has been presented, this would be written as 14 all over, remember, 3x power 1 over 3. There the power is negative, under the division sign it will be positive, and then you have 10 over x power 6. Rewriting this part here, I'm going to have 14 all over 3 cube root of x, and then I have minus 10 over x power 6. This would be my final solution. Right, now I want to say something here. Distribution of the 3 marks. These 3 marks, how are they distributed? These 3 marks, it's going to be, as they will be distributed as follows. You're going to get 1 mark for that part there, that part, 1 mark. And then you're going to have 1 mark for this expression here, and then you're going to have 1 mark for that expression. So it's the whole of this and then the whole of that. They don't usually give you marks for that. So that will be your 3 marks. Finally, 7.3. 7.3, let's just go through 7.3. That's page 3. Page 3. Question 7.3 says here, take note of this. It says, for which values of x will the tangent to f of x equals this have a positive gradient? See, I told you that you're going to have first principles, rules of differentiation, and then they will add one question that has something to do directly with the derivative. So positive gradient, it means we're basically supposed to differentiate this and say greater than 0, because that's what positive gradient is. Remember, derivative is gradient. Derivative is gradient of a tangent to a curve. So we are told f of x is equal to minus 2x cubed plus 8x. I'm going to go straight because of time. F prime of x is going to be equal to minus 6x squared plus 8, if you agree with me. And for positive gradient, this must be greater than 0, we are told. So it means we have to solve this inequality now. Minus 6x squared plus 8 is greater than 0. I'm going to multiply by minus 1 throughout. So I'm going to get, or if I like, divide by minus 2 throughout. So it will be 3x squared minus 4. Remember, when you divide by a negative number, the inquiry sign must change. So from here to there, I divided by minus 2. Divide that by minus 2, you get this. Divide by minus 2, you get that. And here, this is what you get. Now, at this stage, we have to work out what we call critical values. Critical values are obtained by equating this to 0. So this is 3x squared minus 4 equals 0. The critical values will be equal, take 4 to the other side, 3x equals 4, 3x squared equals 4, and then x squared equals 4 over 3, dividing by 3 throughout. And then what do I do next? I take square root, so x is going to be equal to plus or minus, remember, square root of 4 over 3. If you like, this is exactly equal to plus or minus 2 over square root of 3. because square root this, remember, square root of a over b is the same as square root of a divided by square root of b. Don't forget that. So these are the two critical values, and looking at this inequality sign here, basically we are saying, if you allow me to use the number line representation, and that being my x-axis, and having a little sketch here of the parabola, the smaller value is minus 2 over root 3. I'll not try to rationalize that because of time. Here I have 2 over root 3, negative, positive. And the inequality sign is a strict one, so the circles here must be open. And if you look at this final part here, it says we're interested in a case where the whole of that function is below x-axis, below x-axis. That's what it means by less than 0. So it's this part here that I'm interested in. So my answer is therefore x must be less than 2 over root 3, and at the same time it must be greater than 2 over minus 2 over root 3. This is the final solution that the examiner wanted for this one. How are the 3 marks distributed? Well, you have 1 mark for that one there. I'm going to give 1 mark for that inequality, although the actual mark should actually be there, but we know this comes from there, so it doesn't matter whether you put it here or here. The other mark will be for critical values, and the other last mark will be for the correct inequality. So that would be how I would distribute the 3 marks. Right, I'm going to stop here in this video. There's one more video on these ideas that I've tried to present in this video and the previous one, and then after that I'll move on to like I said, product rule, quotient rule, and chain rule for university students. I'll come back to grade 12 differential calculus. I'll be focusing on applications. All right, I'll stop here. If you're new to the channel, please support us by subscribing, inviting friends to subscribe. Let's share these videos for the 2025 grade 12 students in the Republic of South Africa. These lessons are going to be extremely critical. Watch my way of presenting this information. I start with content and then I come to past exam questions. And this is how you pass with flying colors. All right, I'll see you next time.